Any other question? Okay, don't take me bad that I don't want to talk about some specific interest. The thing is, we have a plan for today, and if I start to go for some specific details, I will go outside what is the plan today, okay? And what I try to do is try to keep the plan and try to keep you going in the direction that we need, okay? However, if you still having question and you are interested, drop me an email and I will be extremely happy to help you, okay? But for this class, I will try to keep the theme focus on what we are going, okay? Okay, I will close the data manager, okay? I close the data manager now. And we don't have data manager open at this moment. Quick suggestion: try to close the data manager if you are sure that you will not use again. Minimize the data manager if you are planning to use again, but try to don't keep 10,000 data manager open at the same time, okay? It's a bad habit that people open. Just press the button, open a data manager, then open another data manager and keep going. That is a very bad habit. Okay, what is my job now? My job now is that we have a single line diagram. We have a single line diagram for the PM Anderson system. And my job now is that we want to create the data inside PowerFactory of this power system. Okay, we have here. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9 bus bars. Okay. And then we have 3 generators, 3 2-winding transformer, 3 loads, okay? I must be honest, PowerFactory is designed to receive data in different ways. The typical way to create power systems and receive data is using the graphic interface, okay? However, later, if you are working in a big company, probably you need to work with extremely big networks, and using the graphic interface to input data is quite tiring, and sometimes it's almost impossible. For that reason, there are another mechanism to introduce data inside PowerFactory using another approaches that they don't require the graphic representation. However, it's not my job here to do so. It's my job just to let you know that there are another mechanism if you are using bigger networks and you need to put data in another way, okay? It's mainly a mechanism that allows you bulk data to be imported inside PowerFactory, okay? Okay, but what is the next step? Again, we are using the graphic interface in order to input the data. However, you must be clear there are different ways to do this activity. Okay, you will see some videos in YouTube. You will see some videos on internet, and some videos even in DIgSILENT. And everyone have a different approach how to build a network. I will give you here a simple way to do it. It's a way that is not the perfect one, but is probably the easy way to input the data. Okay? For that reason, we will start the introduction of data, but including or creating the buses, the bus bars that we need inside the system, okay? What I will do is I will reduce a bit the size of this. Let me try to reduce a bit the size, and I will try to keep this here. And let me try to do this. Okay. No, Okay. Now I need 9 boost bars, okay? And there is a classical question. Here on the right side, you have the drawing tool. If you would like to have more information, less information, there are 2 new features. This is especially for newer users. This feature is quite amazing because originally we received the data in PowerFactory in something like this, without any names. Okay, this is the classical way that version 2019, 2018 and below, we have the graphic window for the drawing tools like this. Okay, and then if you want to know the name, you need to go and use the cursor and put on top the cursor, and you will receive the help balloon. And the help balloon will tell you, okay, this symbol represents a boost bar, this symbol here represents a double boost bar, that symbol over there represents a line. However, PowerFactory has been extremely helpful this year with the version 2020, and now you have here a couple buttons, and those buttons allow you to combine and receive more information about the devices. Okay. Okay. I think I will start to receive questions at this moment, but I will try to do my best here. The 9 bus systems, there are 9 buses installed inside the system. Now, as you can see on the right hand side, there is a drawing tool, and they are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, at least 14 different types of boost bar. Okay, and you will probably wondering, okay, Professor, which one do we need to use? Well, on the top, you will see that this section say boost bars and terminals. That means that is the most simple model for a boost bar. It's the most simple model because it's just like a node inside a circuit. It's a connection point, and you can connect over there several branches, and that is a single terminal, or that is a terminal. Below, you will find the boost bar systems. What is the boost bar systems? Well, if you remember my classes about power system protection, substations in real life, they have an arrangement of many equipments, and in those arrangements sometimes we use redundancy in order to create reliability. For that reason, we have several types of boost bar schemes. If you remember my classes, for instance, one boost bar scheme is the double boost bar that is extremely reliable, but you have then many components because you are using redundancy to increase the reliability. I will not go in and complicate your life. Boost bar systems are designed when you want to create the full model of the substation and you are interested on what is inside the substation, how many bays, circuit breakers, sectionalizers, and so on. However, if you just want a connection point between elements, you can use the terminal as it, and that's all. Okay? For this very basic exercise, I will use the first boost bar that you will find on the top, and that is the classical boost bar that is called also terminal. Okay, we need 9 of them. I will press the button. Okay, when I press the button, you will realize that the icon now has close to the icon, close to the cursor, we have the icon for the bar, and then we can click on the graphic window 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, I don't know if you realize, but because I click the boost bar, the icon is defined to install boost bars in the graphic window each time that I press click. I press click here, there, somewhere. But at the very end, I don't know if you realize, but the icon of the terminal is still attached to the cursor. The only way that I can release, the boost bar from the icon is pressing escape. When you press the key escape, now the boost bar is released from the system. Okay, now you have over there 9 buses, and those buses are near to the location that we are using. Okay, now let me stop here because probably somebody will have a question. Let me put an open questions. Any question about boost bars, terminals, or how to install them? Okay, I didn't receive any question. I believe we are clear to keep going. Okay, it's extremely simple. We installed 9 terminals. Something that you must realize is now you have 1, 2, 3, 4, 5, 6, 7, 8, 9 boost bars. Okay, those are the graphic representation in your single line diagram of the 9 bus. Okay, however, you must realize that the names are not the name that we want to use. Also, they are in gray color. I will explain what does mean the gray color, but the gray color means that they are not right now energized because they are not active component inside the power system. Okay, what I want to do is the following. If you are with me, I open the data manager. Okay, if you open the data manager and you go here to network, okay, it's extremely simple. I open the data manager. Then when I open the data manager, I went to the folder that is called PM Anderson, and then I went inside the folder that is called network model, and then I went inside the power network. Okay, what is my idea here? My idea here is that you can identify the location of those terminals. You can see over there terminal 1, 2, 3, blah, 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 until 8, and they are located inside the folder power network. But something that is extremely important that you must be aware right now is the icon is green color. Green color means this is an object and this is an element. Okay. Now let me show you the following. Okay. Let me show you the following. I will minimize the data manager, and now I will open where is located the bus bar number 1. The bus bar number 1 is here at the bottom. Yes, you can see here is the number 1. What I will do is go to the position and double click the number 1. Okay. If you are with me, I just double click the bus bar that is located at the very bottom of the diagram, and I will change the name, the log name of this one, and now the name will be bus number 1. Okay? Very simple. Bus number 1. But I don't know if you can see, but the bus number 1 is an element terminal. Let me put here. Where is the visualizer? Looking for the visualizer. If you are with me, you will realize that now you have a symbol, an icon. Then you have the word terminal. Then you have the location. Yeah. Then you have the new name. And then you have and in this case, this is an element. And this is a terminal. Terminal is like any node in a power system. In a circuit, you can have many branches. Some of them bringing current into, feeding current into the nodes. Some branches putting current out. And that is the most basic representation for a bus bar inside PowerFactory. This is the LM terminal. Okay, this is an element, and the name is terminal. Okay, good. Okay. However, we changed the name, but we need to care about the voltage. What is the voltage of that bus bar? Okay, if you remember, we have here a table. That is the table 4.2, and you can see in the table 4.2 that the nominal voltage is 16.5 kV. For that reason, we put here 16.5 kV, and now we are completing the data. Okay. 16.5, bus bar number 1, done, and we say okay. What is the beautiful thing here? The beautiful thing here is we got the bus bar with the real number, bus bar number 1, and we have the proper voltage, 16.5 kV. Okay? Now I will do this a bit faster because we need to complete the data of bus bar number 2, bus bar number 3. Bus bar number 2 is 18 kV, and bus bar number 3 is 13.8. Well, let's do this quite fast. Let's go for bus bar number 2. bus bar number 2, the name is bus 2, and the voltage is 18. Okay? Then we go for bus bar number 3. The log name is bus 3, and the nominal voltage is 13.8 kV. Okay? Now you can see we have the bus bar 1, 2, 3 with the nominal voltage, but there are 6 more bus bars that they require names and voltages. Okay. What I will do now is I would like to speed up things. Okay. What I will do now is I will go for bus bar number 4, number 5, 6, 7, 8, and 9. And you must remember something that is extremely important here. Bus bars 4, 5, 6, 7, 8, and 9, all of them are in the transmission system. All of them, the nominal voltage is 230. For that reason, we can do the following. Let's start with the names. This is bus bar number 4, 230. Then bus bar number 5, 230. Then bus bar number 6 on the right, bus bar number 6, and it's 230 kV. Then we will go to the right, and this is bus bar number 7, again 230 kV. And then to the right, bus bar number 8, and the voltage is 230. Finally, we have bus bar number 9 on the right, and this is 230 kV, and done. Okay. Right now we have whole 9 bus system with the voltages defined in each bus bar, and also the names properly done. Okay. I will do something here. I will show you another trick, but before I do that, I will ask all of you: do you finish with the completing the data of the 9 buses? If you are done with that data, please put a thumbs up at the okay, 1, 2, 3, 4. Okay, good. There are two people over there. Okay, 1, 2, 3, 4, 5, 6, 7, 8. No, there are 4 people that they didn't answer. Lars is missing. Mr. Latif is missing. Mr. Latif say yes. Mr. Busal is still with the hand ups. Mr. Helborg disappeared. No, Mr. Helborg is okay. Who else? Mr. Monoranjan, I think that is the pronunciation. Sorry about. Okay, are we ready? Please put thumbs to the normal position. Normal position for the thumbs, please. Thank you. Okay, I want to be sure that I put the correct data. We are working in a small system. We are using only 9 buses. Probably simple going one by one, but to be honest, if you are using something a bit bigger, going one by one is a bit time consuming. For that reason, there is a button on the right side of the data manager. Okay. To be honest, that button is relative new inside PowerFactory. I will say probably 2 or 3 years, I don't remember. But that button is extremely useful. If you press that button, you will realize that that is what they call the network model manager. Okay, in the network model manager is like, let's say, the younger brother of the data manager. I call the younger brother because this button allows you to see some information that is already in the data manager, but is filtering the data to the data that is active inside your project. Okay. And now you can go, if you are with me, you can go to the bus bars, and you can go to the terminals, and you will see the same. Okay. And you can see the names over there, bus bar 1, 2, 3, 4, 5, 6, 7. Everything is fine over there. You can see the voltages. Look over there. Nominal voltage in bus bar number 2. What we can do is the following. We can be sure that we put the proper data. Let's see. Let me compare here. Let me zoom in here. Okay, I believe you can see over there, bus bar number 1, 60.5, bus bar number 2, 18, bus bar number 3, 13.8, and from bus bar 4 to 9 is 230. We are fine. Congratulations, well done. Okay? Okay. Next step. The next step is probably just cosmetic step. Okay? Why is cosmetic? Because the original system looked much better in this way. I believe you can see that bus bar number 2, 7, 9, 3, and 8, they have a different orientation. Okay? What I'm trying to say is that right now they are in the single line diagram, horizontal, and to be honest, those bus bars should be vertical. What is the best way to solve this problem? Very simple. You go to the bus bar, yes, select the bus bar, then right button, and remember, every time that you use the right button in PowerFactory, you have a menu, and here you can find several options. And one of them is, okay, we can rotate 180 degree, or we can rotate using clockwise direction or counterclockwise direction. What I will do now is rotate clockwise. Okay, then I will rotate this one clockwise, this one clockwise, then this one clockwise, and then this one clockwise. But bus bar number 8 is outside the single line, and I will put back. Okay. Now the one thing that I don't like is that the names, they are vertical, but that is another thing that you can solve just rotating the names. Again, what you need to do is rotate, but I don't want to do that. This is cosmetic. If you want to do it at home, it's fine. For my numerical purposes, the system like right now is perfect for me. Okay, probably I need to move a bit more this bus bar here, moving this bus bar there, probably this one a bit more here, but we are fine. Okay. Okay, well, congratulations, you have finished the installation of the 9-bus system. Okay, what is the next step? Okay, the next step is we finish with the lines. Now we need to install, we need to define generators transmission lines, loads, and 2 winding transformers, okay? Let's do the following. I will start with transmission lines. They are at least 2, 4, 6 transmission lines. Find the transmission lines in the drawing tool. I think it's extremely simple. All my students can do this. They can find where is located. Oh, here, yes. Okay. If you select the button for the transmission line, you will realize that now you have the transmission line icon attached to your cursor. And now what you need to do is start to connect your transmission lines. I will start with the basic ones. What are the basic ones? For instance, the transmission line between bus bar number, no, this is not a transmission line. Transmission line between 7 and 8, simple. Transmission line between 8 and 9, simple. Then I have here something that I would like to teach you. I don't know if you realize, but the line between 5 and 7, there is a 90-degree corner over there. How do you do that? Well, very simple. You click here, and now the transmission line is connected to bus bar number 7. But every time that you click, you are defining a corner in the transmission line. Now I define a corner here, goes down, and connect my transmission line, and now the single line looks similar to the one that is given you in the document of chapter number 4. Now again, click at the bus bar, then click here because I want a corner, 90-degree corner, then goes down, bus bar 6. Beautiful, similar to the single line diagram that I show you, okay? Now I have a small problem with the transmission lines connecting bus bar number 4. It's not a problem, it's just a small issue. If you look over here, the bus bar number 4 is a bit longer, and to do the bus bar a bit longer, what you need to do is go back here to PowerFactory. You select the bus bar. Selecting the bus bar, you can move the bus bar wherever you want with a click. But if you want to extend, what you need to do is click at the very end, then release at the location that you want, and now we have a bus bar that is a bit longer, okay? Now the bus bar is similar to the bus bar in the single line diagram. You can see here, beautiful, I like it. Good. But then, what I need to do is connect the 2 other transmission lines, transmission line 4.6, transmission line 4.5, okay? Let's do it. Transmission line 4.6, done. Transmission line 4.5, done. And we have the beautiful transmission system done. I would like to move this a bit to the left. I want to move this to the left. And now we have the beautiful transmission lines already installed. Okay. Let me move the bus bar number 1 to the right, to the left, sorry. Beautiful, I love it. Okay, my dear students, let me go back here and make a question. Do you have any question right now about the transmission lines? Well, I don't see any question about transmission lines, okay? My students love breaks. At this moment, I would like to take a break, okay? And we will come back at 12, 15-minute breaks, okay? Right now is almost 11:45. We will reconvene at 1200 hours. Okay, that is noon. Okay. However, if you have any question, please feel free to drop me the question here in the chat. Okay. Okay, my dear students, now I am totally back here, and the plan now is to we check the data and we connect the transmission lines, and we have the transmission lines over there. Okay, something that I want to do straight away is I will change the names of those transmission lines. Okay, in this system, the lines, if you double click one of them, let me click the line that is between 5 and 7. Yeah, if you are with me, you will realize again that PowerFactory is talking to you. PowerFactory is showing you, you can see on the top of this you can see that this is the symbol. Yeah, that is the symbol for the okay, we have a problem here with the okay, now it's much better. No. Okay. You can see at the top we have the line. This is the object and it's inside Power Network. And in this case we need to change the name. In this case the line will be the line between bus bar 5 and 7. Let me use as name line 57. Yeah, okay, line 57, and let me keep my explanation about here. We are in the transmission line that is line 57, and 57 is located inside Power Network, and this is the element. This is the element. Okay. Okay, something that is extremely important here is we are using an element, an object that is a transmission line that is connected between bus bar number 5, number 7. Okay, and the other important thing that you need to know here is that the length of this transmission line is 1 kilometer. Okay. However, you must realize that the element transmission line has not electrical data at the moment. I mean, if you look here on the right hand side, there is a small dialog, and this small dialog is showing 0 kiloamps, 0 ohms, and so on, because we has not put any electrical data at the moment into the transmission line. I will do that in a few minutes, okay? But let me change the names, okay? This is the line 57. This is the line 45. This is the line 46. 4 and 6, and this is the line 69, and this is the line, this is the line 89, and finally there is one more transmission line, the 6th, and this is the line between bus bar 7 and 8, okay? Okay, right now let me put a zoom here. You can see much better. Now we have the transmission lines and we have the names over there, but there is no electrical data, okay? Now let me move a bit forward. Let me install the transformers. As you can see on the drawing tool, in the drawing tools, there are different types of transformers. You can see some transformer, 2-winding transformer, 3-winding transformer, auto transformers, and so on. In this example, I need 3 transformers, but very specific case, 2-winding transformers. For that reason, I will click here. And now we have the transformer icon connected to or attached to the cursor. Okay, let me connect here. One transformer, another transformer, and the third transformer. Extremely simple. We have now the transformer T1. We have the transformer T2, and we have the transformer T3, okay? Again, what I did is double click. When I double click, I got access to the data of this transformer. And if you are with me, hopefully yes, you are with me, and hopefully you will see that in this case, this is the element TR2, okay? This is the element TR2. What does mean TR2? Well, the element TR2, now we have a problem with focus. No, that is not the problem. The camera is not focusing properly. Why not? Okay, let's see. Okay, right now we are using an element, and this is the element 2-winding transformer. And this is the element, okay? Okay, we are completing the data of this transformer, something that you must be very careful with transformers. There is a high voltage side, there is a low voltage side. As you can see over here from the single line diagram, you can see that bus bar number 1 is connected to the generator. This is the low voltage, and number 4 is the high voltage. That means that the transformer number 1 is properly connected. Okay, now let's check the transformer number 2. Now let's see. Transformer number 2 is connected between low voltage is bus bar number 2. Bus bar number 7 is high voltage. For that reason, transformer number 2 is properly connected. Finally, let's see transformer number 3. Transformer number 3, low voltage is bus bar number 3, high voltage bus bar is number 9. We are connecting properly our transformer number 3, okay? Good. At this moment, there are only 2 elements missing. One of them is the synchronous generator. Synchronous generator is extremely easy to find. On the drawing tool on the right hand, you can see here the synchronous machine. Select, and we can put here one synchronous machine, another synchronous machine, and another synchronous machine, okay? We have installed 3 synchronous machines. The synchronous machine here connected to bus bar number 1 is the generator number 1, okay? Something that you must be aware is that now we are using another element, okay? In this case, this is the element SYM, and that means this is an element. That is the reason for the green color, and this is synchronous machine. My student must be aware that synchronous machine is the electrical machine, but this electrical machine can be generator or it can be working as a motor, okay? If I go back again to PowerFactory, you must realize that this is the element synchronous machine. You can read on the top, but here you must define if this is a motor or this is a generator. PowerFactory use as the full configuration generators, okay? That is no problem. But if you are working with synchronous motors, you must be careful because you must change the configuration over here and define the operational mode as a motor, okay? But this is the generator 1. Let me change the name for generator 2. Generator 2 over here. And finally, generator number 3. Generator number 3. And we are almost near to the conclusion of the single line diagram. What is missing here is that now we need here at least 3 loads, and I will connect those loads here. If you remember the single line diagram, there is a load in bus bar 8, there is a load in bus bar 6, and there is a load in bus bar 5, okay? What I will do now is find the loads, and there are few different types of loads. There are medium voltage loads, there are low voltage loads, there are general loads, okay? In this power system analysis course, we are not using medium or low voltage loads. In this course, we are using only general loads, okay? For that reason, click here, load, and one more load, okay? And now it's time to define the names. This is the load B. This is the load A. And finally the load Z, okay? Well, I want my diagram to look similar to the original one. For that reason, what I will do is I will move this load to here, and right now look much better compared with the original one, okay? Okay, now my dear students, congratulations, you have finished the single line diagram, okay? The single line diagram is just a graphical representation, okay? It's a graphical representation, And you must be careful, because when you are doing the single line diagram, you are not including more data, just the graphic data, defining the connectivity between the devices, okay? It's just defining connectivity between devices, names, but no more than that, okay? Now I must stop here, and I must ask all of you if you have installed, or if you have any question about transformers, loads, or generators. Okay? If you have any question about loads, generators, or two-winding transformers, feel free. Oh yes, he has the microphone on, yes. Any question about transformers, loads, and generators? Okay, there is another question here. Any single device, let me go to PowerFactory, okay? Every single device in PowerFactory, electrical device, what is connected to a terminal, let me open the visualizer, okay? In PowerFactory, you have here the, let's say this is the T1, and this is a element terminal, okay? When you connect here the synchronous generator, okay? When you connect here the synchronous generator, this is the bus bar, okay? This is the terminal. But the terminal can have many places that you can connect, okay? In PowerFactory, this connection point receives the name cubicle, okay? For instance, if you look right now, sorry, this is bus 1. If you are talking about the generator number 1 that is connected to bus bar number 1, the cubicle is CUB2. Now somebody is asking me right now if that is relevant. No, I mean, at this moment, when you connect, when you graphically connect your generator to the bus bar, PowerFactory automatically gives you a cubicle for that, okay? However, if you are using the full model of substations that we are not using here, if you are using the full model of substation, of course you need to care about what cubicle you are connecting your device. But for any other case where you don't have to use the full representation at the substation, you don't care about this cubicle number for normal power system analysis, okay? Probably for protections, you can care about cubicles, but for the present moment, it's not relevant, okay? Okay, I think this answers the question. And may I ask again, do you have any other question at the moment? Okay, if we don't have any other question at the moment, I need to move a bit faster now. And now it's time to complete data for the real components, okay? At this moment, what you have over there is just a single line diagram that you have some terminals, some loads that you have names, some synchronous generators, some lines, and 2 winding transformers, okay? But in order to perform any